Chapter 5, Force. This lecture will help you understand force in the law of acceleration, gravity, and weight. Newton's second law of motion is the law of acceleration. The acceleration produced by a net force on an object is directly proportional to the net force. It is the same direction as the net force and is inversely proportional to the mass of the object. Newton discovered that the acceleration of an object depends directly on the force applied. You double the force, you double the acceleration. Newton also discovered that the acceleration is inversely proportional to the mass. Double the mass being accelerated, and the acceleration is half as much. What is a net force? When more than one force acts on a body, the net force, or the resultant force, is the vector combination of all the forces added together. It is the net effect of all the forces. Newton wrote this in his force law: the acceleration is equal to the net force divided by the mass. Remember, the net force is the vector sum of all the forces experienced by an object. Symbolically, this is written as A, the acceleration, is equal to F sub net, the net force, divided by the mass, M. I want to make an important point here. The two equations are mathematically identical, but they have a different physical meaning. In the first, a force causes a mass to accelerate. In the second, we are finding the force that caused an acceleration. Accelerations never cause forces, but forces always cause accelerations. Since force is measured in newtons, mass in kilograms, and acceleration in meters per second squared, we see that from F equal ma, that 1 Newton equals 1 kilogram times meters per second squared. In the English system of measure, force is measured in pounds, mass is measured in slugs, and acceleration is measured in feet per second squared. We see from F net equal ma the relationship between pounds and slugs. 1 pound of force is 1 slug times 1 foot per second squared. In a further confusion of the use of the term pound, we have the terms pound mass and pound force. The slug is the standard unit of mass in the English system. 1 slug is equal to 32.17 pound mass. 1 pound mass is the mass that weighs 1 pound in 1 g of gravity. Consider a cart pushed along a track with a certain force. If the force remains the same while the mass of the cart decreases to half, the acceleration of the cart A remains the same, B halves, C doubles, or D changes unpredictably. For C doubles. Study the equation carefully. The new mass is half the old mass, which results in twice the acceleration. Push a cart along a track so twice as much net force acts upon it. If the acceleration remains the same, what is a reasonable explanation? The mass of the cart doubled. When the force doubled, the cart experiences force that it didn't before, the track is not level, or friction reversed direction. A. The mass of the cart doubled when the force doubled. Study the formula so you can see the relationship between mass, force, and acceleration. When the only force acting on a falling object is gravity, with negligible air resistance, the object is in free fall. An object in free fall accelerates toward the Earth at 9.80 meters per second squared, or 32.2 feet per second squared. The symbol given to the acceleration due to gravity is g. For many applications, we can use 10 meters per second squared for the acceleration of gravity. At one instant, an object in free fall has a speed of 40 meters per second. Its speed 1 second later is also 40 meters per second, B, 45 meters per second, C, 50 meters per second, D, none of the above. We assume the object is falling downward and g is 10 meters per second squared. So the answer is C, 50 meters per second. We've added 10 meters per second to the initial velocity every second. The value of g is constant no matter where mass is falling. Twice the force or twice the mass gives the same acceleration as half the force or half the mass. A 5 kilogram iron ball and a 10 kilogram iron ball are dropped from rest. For negligible air resistance, the acceleration of the heavier ball will be A, less, B, the same, C, more, or D, undetermined. Answer is B, the same. The acceleration of gravity is the same no matter what the object's mass. A 5 kilogram iron ball and a 10 kilogram iron ball are dropped from rest. When the free-falling 5 kilogram iron ball reaches a speed of 10 meters per second, the speed of the free-falling 10 kilogram iron ball is A, less than 10 meters per second, B, 10 meters per second, C, more than 10 meters per second, or D, undetermined. Answer is B, 10 meters per second. All freely falling bodies fall at the same rate, regardless of mass. On Earth's surface, the acceleration due to gravity is approximately constant and directed toward the center of Earth. We will explore variations in the acceleration of gravity in later chapters. Mass and weight are two different properties of matter. Mass is a physical property of matter that explains how much matter is in an object. Mass does not change when gravity changes. Weight is a force which is calculated by multiplying the acceleration of gravity times mass. Weight can change when gravity changes. Mass versus weight. Mass is the amount of matter in an object. Weight is a measure of the Earth's gravitational pull, a force. The typical units of mass are grams or kilograms, while the units of weight are pounds or newtons. Mass does not depend upon gravity. Weight changes depending upon the gravitational force. Mass is measured with a triple beam balance or a digital balance. Weight is measured using a spring scale. Standard units in the English and the metric system for mass and weight. These are important to remember. In the English system, weight is measured in pounds. The acceleration in feet per second squared. The mass is in slugs, and forces are measured in pounds. In the metric SI system, weight is measured in newtons, acceleration in meters per second squared, mass is measured in kilograms, and the force is measured in newtons. Here's an example. A mass of 2 kilograms is accelerated at 5 meters per second squared. What force is required to achieve this motion? The basic equation is that the acceleration is the force divided by the mass. The working equation is the force equals the mass times acceleration. We are given the mass and the acceleration, so the force can be found as 10 newtons. An object has a mass of 2 slugs. What does it weigh on Earth? The basic equation and the working equation are the same. The weight equals the mass times the acceleration of gravity. Substituting what we know gives a weight of 64.4 pounds. Here's the acceleration of gravity on various planets in terms of meters per second squared.